We will now discuss the important concepts that you need to know to do the next 3 chapters: temperature, ideal gases, and thermodynamics. A. Thermal equilibrium. You need to understand that thermal energy is transferred from a region of higher temperature to a region of lower temperature via conduction, convection, or radiation. Then you need to be able to define thermal equilibrium, and that at thermal equilibrium, there's zero energy transferred, and the two regions will be at the same temperature. Part B, Section B, temperature scale. Understand that a physical property that changes with temperature may be used to measure temperature. Examples include the density of a liquid, volume of a gas at constant pressure, resistance of a metal, and EMF of a thermocouple. Understand that the scale of thermodynamic temperature does not depend on the property of any particular substance. And then understand that the lowest possible temperature is 0 Kelvin on the thermodynamic temperature scale. 0 Kelvin is also known as the absolute zero. Then you must be able to convert temperature between Kelvin and degrees Celsius, either by reasoning or by using the formula temperature in Kelvin equals to temperature in degrees Celsius plus 273.15. To simplify our calculation, we will use 273 instead of 273.15. Section C, specific heat capacity and specific latent heat. Clarify that specific refers to any value per unit mass. Therefore, you must be able to use and define specific heat capacity and use and define specific latent heat. Understand that latent means hidden. Then you must be able to distinguish between specific latent heat of fusion and specific latent heat of vaporization. Understand that at thermal equilibrium, a substance with a higher specific heat capacity stores more energy. Then you must be able to perform calculations involving specific heat capacity and specific latent heat. Section D, ideal gases. Understand that mole is a base unit and relate it to the number of molecules and Avogadro's constant. Understand that a gas can be described by its temperature in Kelvin, volume, pressure, and quantity. Introduce Boyle's law as the relationship between the pressure and volume for fixed temperature and mass of gas. Introduce Charles' law as the relationship between temperature and volume for fixed pressure and mass of gas. Then finally introduce the pressure law as the relationship between pressure and temperature for fixed volume and mass of gas. Then you must be able to combine all the three laws to make the ideal gas equation. Understand that a gas obeying PV proportional to T, where T is the thermodynamic temperature, is an ideal gas. Recall and use the equation of state for an ideal gas expressed as PV equals to nRT, where N is the quantity of substance in moles, and as PV equals to nKT, where N is the number of molecules. Recall that K is called the Boltzmann constant, and it is given by K equals to R, which is your molar gas constant, divided by Na, which is Avogadro's number. State the basic assumptions of the kinetic theory of gases. And then you must be able to explain how molecular movement causes the pressure exerted by a gas. Be able to derive the relationship PV equals 1/3 Nm C square, where C square is the mean square speed. Understand that the term root mean square speed and be able to calculate it. Compare PV equals 1/3 Nm C square with PV equals nKT to deduce the average translational kinetic energy of a molecule is 3/2 kT. Section E, internal energy. You must be able to define internal energy as the sum of a random distribution of kinetic and potential energies associated with the molecules of a. Understand that the internal energy of an ideal gas is only due to the random kinetic energy. The potential energy is zero. Relate a rise in temperature of object to an increase in its internal energy. Relate internal energy to the changes of state and ideal gas laws. Cooling a substance decreases the internal energy and reduces the pressure. Heating a substance increases its kinetic energy and may increase the potential energy if the substance changes state. Section F. The first law of thermodynamics. Recall and use W equals to P delta V, where W is the work done, and then delta V is the change in volume. For work done when the volume of the gas changes at constant pressure. Then understand the difference between work done by the gas and work done on the gas. Recall and use the first law of thermodynamics. Delta U equals to Q plus W. Your U is your internal energy, Q is your heat energy, and then your W is your work done. Understand how the internal energy of a system changes as heat energy enters or exits the system and as positive or negative work is done on the gas. Section G is a formulae. Section A, B, and C are for temperature. Section D is for ideal gas. Section E and F are for thermodynamics. That means this chapter consists of 3 different chapters: temperature, ideal gas, and thermodynamics. But we'll consider these 3 chapters as one chapter. You need to remember the formulae for this chapter to solve numerical questions. The key is to identify the variables given and then selecting the right equation to use. The important formulae for this chapter are given below. There are 10 formulas here. You can see that the equations for the 10 formulas are given here. We will demonstrate how to use the formula when we answer the past examination questions. Part H, past examination question. These are the examination questions that has appeared in the past exam from February, March 2022 to May, June 2023. You notice there's at least one question on this chapter every year.